The quest to slow aging and reverse degenerative diseases has brought intense focus to senescent cells, damaged, non-dividing cells that linger in the body and fuel chronic inflammation, tissue dysfunction, and age-related decline. While synthetic senolytic drugs are under active development, a particularly exciting area of research involves naturally occurring compounds, many of them derived from plants, that appear capable of selectively clearing senescent cells without harming healthy tissue. Among these, ovanillin, physidin, and quercetin stand out as promising candidates, offering a potentially safer, food-derived alternative to pharmaceutical interventions for those seeking to enhance health span and resilience as they age. Ovanillin, a metabolite of the common food additive vanillin, has shown surprising senolytic activity in preclinical studies. While best known for its flavoring properties, ovanillin has been identified as a compound that interferes with the inflammatory secretions of senescent cells, particularly those involved in cartilage degradation and osteoarthritis. In cell culture and animal models, ovanillin reduces the expression of key SASP, senescence-associated secretory phenotype, markers, including IL-6 and MMP-13, which are strongly implicated in tissue breakdown. Not only does it reduce inflammation, but in some studies, it has also been associated with selective apoptosis, programmed cell death, of senescent chondrocyte, without affecting healthy cells. This dual benefit makes it an intriguing, low-toxicity option for targeting senescence, especially in joint-related aging. Physidin, a flavonoid found in strawberries, apples, and onions, has gained attention for its broad-spectrum antioxidant, anti-inflammatory, and senolytic properties. Among natural compounds tested, physidin has demonstrated some of the most potent effects against senescent cells in multiple tissues. It appears to act through several mechanisms, including reducing oxidative stress, downregulating pro-survival pathways that senescent cells rely on, and rebalancing mitochondrial function. In mouse models, physidin administration not only reduced the burden of senescent cells, but also extended median lifespan and improved physical function. These outcomes have prompted the launch of early human trials investigating physidin as a senolytic agent for aging, frailty, and metabolic disease. What makes physidin especially appealing is its availability as a dietary supplement with a relatively favorable safety profile, although the optimal dosing for therapeutic senolytic effects in humans is still under study. Quercetin, another plant flavonoid abundant in capers, kale, and red onions, has been the subject of senolytic research both alone and in combination with the leukemia drug dasatinib. This pairing, known as D plus Q, was one of the first senolytic regimens to show success in eliminating senescent cells in animal models of aging and improving cardiovascular, pulmonary, and metabolic function. Quercetin by itself also demonstrates senolytic activity, particularly in endothelial and mesenchymal stem cells, where it disrupts pathways that allow senescent cells to resist apoptosis. In early human pilot studies, short-term treatment with quercetin, along with dasatinib, reduced markers of senescence and inflammation in patients with idiopathic pulmonary fibrosis, a disease closely linked to cellular aging. While more work is needed to confirm quercetin's efficacy as a standalone therapy, its accessibility and tolerability make it a compelling candidate for integrative strategies targeting senescence. Importantly, these natural compounds differ from pharmaceutical senolytics in that they tend to be less potent but also potentially safer, especially for long-term or intermittent use. Their lower toxicity profiles and history of dietary exposure make them attractive for preventive or adjunctive approaches to age-related disease. However, because most of the existing research comes from animal or in vitro models and human data remains limited, these compounds should be approached with realistic expectations. The senolytic activity seen in cell cultures does not always translate neatly into whole-body human effects, and factors such as bioavailability, metabolism, and tissue targeting are still under investigation. That said, the concept that everyday foods or supplements could contain molecules that not only support health, but actively remove harmful aging cells is powerful. These plant compounds hint at a future where senescence can be addressed not just in the lab, but through more natural, integrative means. As the science matures, we may see combinations of dietary senolytics used strategically alongside exercise, fasting, and stress reduction practices to synergistically reduce cellular damage and extend healthy lifespan. In the end, natural senolytics like ovanillin, physidin, and quercetin offer more than a novelty. They represent a bridge between longevity science and practical, accessible interventions. While they are unlikely to replace targeted drugs in high-risk or advanced cases, they may help create a preventative foundation, slowing the tide of senescence and its damaging effects on tissues over time. For a society facing the dual pressures of rising life expectancy and chronic disease burden, the idea that age-related decline could be managed, at least in part, with compounds found in nature is both scientifically grounded and profoundly hopeful.